Welcome to the Artists of Data Science Happy Hour. It is Friday, July 2nd. I'm super excited to have all of you guys here. What's up, everybody? Funneling into the room, man. Super excited to have all you guys here. Hopefully, you guys got an opportunity to tune into the podcast, release an episode today with the one and only Dr. Jordan Ellenberg. He's the New York Times bestselling author of How Not to Be Wrong, The Power of Mathematical Thinking, as well as this book right here, Shape. It is an amazing book. Absolutely enjoyed reading it. Absolutely enjoyed discussing it with him. I'm actually going to be giving away this very copy right here. Dr. Ellenberg was generous enough to send me 2 copies, so gonna be giving one away. How can you win one of these? Well, it's easy. Just go on to LinkedIn and share this video with your network. I'm going to randomly select somebody who's shared this video on LinkedIn or is sharing this live stream. And we'll figure out who's going to win this copy. But great book. I really enjoyed it. You guys can enjoy it too. If you want to win your copy, go and share this live stream right now on LinkedIn. Yeah, man, super excited to have all you guys here. The room is packed, man. Look at all these wonderful friends here, man. I'm excited to have everybody here. Mark, what's up? Eric, what's up? Russell, Rashad, what's up, man? Super excited to have all you guys here. Hey, I got a question that we can start getting kicked off with. So I got a few of them here, but let's start with one. So what's a topic that you decided it's finally time for you to go in on, right? Because we all know that not only is data science a broad field, but just like life in general, there's so much stuff to learn out there. What's something that you have finally decided that it's time to go in on, and why that? Why that book? Why that topic? For me, this week I've decided that, you know what, it's been far too long. I've been putting it off for way too long. I'm going in on natural language processing, and that's the route I'm taking. I feel like there's a need for it for me personally on, with the podcast and all the transcriptions I have. I feel like I can apply natural language processing to that data and extract some really valuable information and insights out of that. So I figured, you know what, it's time for me to go in on that. What about you guys, man? Let's start out with Rashad, and shout out to Greg Kokio in the house. But Rashad, man, what's something that it's just been far too long, and you decided it's time to go in?
Oh, well, the far too long is really easy. It's audio analysis. Because when I first got into data science, I love music. In fact, I was just strumming my guitar right before this. And I really wanted to work for Spotify or something, and to create the ultimate music recommender. So it's also unlike, say, a lot of the real estate finance analysis that I do at work. It's like a very different starting point. It's like a signal, you decompose it. There's a lot. It's like a very different way of thinking. So it's very refreshing. So I've been getting into that, like actually just going on LinkedIn, finding some presentations that people put up. I'm sure I'll find talks eventually too, but I've been going in that slowly.
Dude, that's so cool, man. Like that's something that I probably would do next, because I like exactly what you're talking about, man. I'm super into music itself, and just doing music analysis and stuff like that. Building recommendation engines like you're talking about would be freaking awesome. Have you played around with like Spotify's API at all? Do they got so many rich data sets that have like these audio features for all these different tracks and things like that? Have you checked that out at all,
I
Rashad?
I have not, but I will put a note to do so in my task tracking app
There's
right
even
now.
a integration with they've got like it's called Spotty Pie for in Python. So it makes it easy to do that. Shout out to Greg Kokio in the house. Alexander, what's going on? Joe Reese taking a walk. Um, Good, man. Happy to have you guys here. So yeah, if anybody's just not much, man, just doing this happy hour thing. Anybody that's just tuning in, if you want to win your copy of Shape, you have to share this live stream right now. I'm going to randomly select somebody at a later date to win this book, but the only way you can win this is if you share this live stream right now. Mark, man, what's something that you've decided it's finally time to go in on?
For me, it's business strategy. And it's like really diving in on, really tying my work to business metrics and like business meaning. A lot of my stuff's been really focused on beforehand, like on startups and just entrepreneurship in that early stage of thinking of it. And I've shied away from like the inner workings of like once something's already established. And now like just talk to my manager and this kind of direction I'm trying to go is like, this is the piece that I need to really upskill on to really take me to the next level. So it's like trying to read some more books on this, going to various courses and training, and just thinking more deeply about this before I just jump into work. So yeah, business strategy. And it's like really interesting too, just seeing all these different levers and frameworks of how people frame these business problems.
Yeah, man. I was actually catching up with Vin earlier today, making up on that session that I had to miss out on. Um, have you checked out the episode I did with Fred Pellard? The book was all about strategy. It's called How to Be Strategic.
I was able to get my colleagues to choose it for the book club, and we got it comped. So we started reading it.
Nice. Yeah. And there's another book too I like called Cracking Complexity. I interviewed the author of that book. That episode should be released sometime later this year, but keep an eye out for that as well. Alexandra, welcome. First time I've seen you here. Happy to have you here. So what's something that you feel like you've been putting off for too long, but decided it's time for you to start picking up and start studying? And while Alexandra is giving us her answer, if anybody else has questions, you can put that right there in the chat, wherever it is that you are enjoying this from, whether it's live in the Zoom room, on Twitch, on YouTube, or LinkedIn. I'll get to your questions. But Alexandra, go for it.
Yeah, thank you. And thank you to Eric. He invited me on via LinkedIn earlier this morning. So thanks you for the invitation. I'm similar to you. I'm trying to work on my natural language processing skills. I come from a marketing background, so being able to understand how consumers are talking about your products, or even I've been dabbling with the Twitter API a little bit to try to do some tweet analysis has been fun. And to connect to Richard's point about also being a Spotify music junkie, I've been using the Genius API a little bit to try to look at the sentiment of song lyrics and things along that line. So trying to really dive into that space.
Is the Genius API, is that the same thing that like Apple did? I mean, I don't know if Apple does Genius anymore with their music, but is that the same thing?
Yeah, I'm not sure if it's exactly the same as what Apple's doing anymore, but the concept is the same, where they're just pulling song lyrics basically.
Nice. That's cool, man. So shout out to everybody else in the room. If anybody got questions, let me know. We'll get to all those questions. Let's hear from man, I hope I don't butcher your name here, but is it Tuli Megameno? Did I say that right? Please help me out here.
Yeah, just say Tuli.
Tuli. All right, Tuli, what is something that you feel like it's finally time to go in and start studying?
Yeah, hi everyone. I attended a few sessions here. It's 12 midnight. So sometimes I have my video on, but it's normally too late. So I'm really happy to be here. Yeah. Well, in fact, I am also doing a bit of NLP. My journey in data science is still quite new. I work in a statistic environment. So recently I started using NLP in analyzing survey data. There's free text that you normally need to analyze and get some information from that. So I've used that recently on a survey that we're doing on COVID. It's quite useful because normally statisticians don't, as much as they collect information, when you fill in a questionnaire, sometimes you have a section where it says it's a bit more descriptive. And in a statistic environment, you deal mostly with numbers. So that text, normally they collect information, but they don't analyze it. So natural processing language really helped me. Just did a basic coding, and you're really able to do some topic modeling, and you can extract quickly information depending on the subject. So that was quite useful. But I'm still learning. I still want to explore more and maybe do a bit more modeling and explore some packages. I actually use R in most cases. So I do Python, but I'm mostly analyze and use R in my day-to-day work.
Yeah, so I used to be a statistician as well. I worked as a biostatistician, clinical trial statistician, studied statistics in grad school and all that stuff. So you and I are kind of cut from the same cloth. Eric, let's hear from you. And by the way, if anybody has questions, let us know. There's some questions rolling in on LinkedIn that we'll get to. But first, after we hear from Eric on this topic, we'll go to a question from Spencer. Spencer emailed in a question, but I'll just have you like unmute yourself and turn your video on, Spencer, if you don't mind. But Eric, go for it.
Yeah, so I think I would have to say, this is kind of like, Mark knows what I'm probably going to say, because I was going to ask a question today about bias in data sets of machine learning. So that's the thing that I'm really interested in and want to dig more into, because like we hear about it, we know it's there, and it's a thing that, you know, there's much hand wringing done over the topic of bias in machine learning, and yet I don't know a lot about quantifying it and mitigating it through algorithmically, and so that's my next big push.
Yeah, it's an interesting topic, man. I like to see what you learn about that and follow along on your journey. If you're sharing that on LinkedIn through posts and stuff like that, man, that would be absolutely awesome to hear about. Shout out to everybody that's just joining in. Remember, you can win a copy of Shape by Jordan Ellenberg if you share this on LinkedIn. Just go ahead, share this entire live stream. Doesn't even matter if it's a couple of days later. Just make sure you share this with your network, and you can win this book right here. It is an amazing read. This is actually a book that it's an advanced version with uncorrected proofs. So hey, giving that one away. So shout out to Spencer Holly. Spencer, go for it. Greg, I've got you added in the question queue as well. And then friends on LinkedIn, I will get to your questions as well. Spencer, go for it.
All right, thank you. So I've been working on getting started with an independent project of like doing an independent project, and I have two ideas in mind that I've dabbled with them a little bit, but I'm gonna really like move forward with one of them. And so one of them is to do lead scoring type of thing for a software company that I have in mind, and the other one is to do like some YouTube analytics. What I have in mind right now is predicting how many sales like a certain YouTube video could do. Like let's say we have a YouTube channel and they're a business that sells like a course that teaches you Python, and then you're like trying to predict how many course sales that individual YouTube could make or could be attributed to that video. And between those two projects, I think that the second one seems more doable, but like I'm more excited about the first one, and I'm kind of worried though if I do the first one, like for example, I can find out which like within the company which customer or which leads did convert, or like who the customers are, but I can't really find out like who's not a customer. So I've got like I've thought of some ways to kind of fill in the gaps and make a really scrappy project. And my concern is that if I do that, I'm just going to have this like kind of odd looking project where I'll have a bunch of like gaps and say like, well, in a normal case, I'd do this, but I'm missing all this stuff. So I don't know. Kind of my question is like how the trade-off between the really scrappy project that might have a bigger impact be versus a smaller project but is actually like has the data fully there.
Yeah, it's a great question. I definitely like this. Eric saying better to have an odd looking project than no project at all. I definitely agree with that as well. Vin, what are your thoughts on this? And let's hear from Vin. Then after Vin, we'll go to Rashad and then Joe. If you want to chime in on this, I'd love to hear from you as well.
Yeah, I like projects that are real world. And so as you're listing, like, here are my problems, that's awesome. That is absolutely perfect, because that's what we deal with. You know, I don't have enough data. Yeah, and we never do. And so any project that you look at and you say, well, it's not going to be perfect, it's not going to be great, those are actually perfect, because what you're going to do throughout the course of that independent project is learn and display your capabilities of handling just real world issues that we come up against all the time. And that makes for such a more rich project, especially when, and I know you want to probably think of the perfect project where you have the perfect results, and that's no project ever. the caveats that you can put in where you say, I started out thinking I could do this, and I realized about 10% of the way through data analysis that I couldn't, and so I pivoted. Those are amazing, because that's real world, where you didn't waste the time. You got to a certain point and you said, hey, I can't do exactly what I initially did, but here are some suggestions where I could still do value. That's stuff that we do all the time. And so think about it that way. Even if it's not the perfect project, think about it in terms of how would this work in the real world? Because those capabilities that you're showcasing to handle ambiguity, setbacks, creatively solve problems that we run into, especially around data, amazing. Those are great.
Thank you very much, Vin. Rashad?
Yeah, I agree with everything Vin said. I think of projects as being facsimiles, a way to demonstrate your performance on a facsimile of the real job. I also think of the interview process. You try to get as close to like, okay, what are you actually going to be doing day to day, and how can I test that? So a side project is like an extension of that. And so if you are working with more imperfect data, but you actually have like a real business case or some like actual thing, like problem you're trying to solve, that's probably the most valuable. And then I'd say, you take a couple steps forward. Oh, I can't do that. And then you do this. If you were able to write about that, that actually shows, wow, that separates you from all the bootcamp people, because then you're like, because that it's a very difficult thing to train unless you actually experience it and do it. So if you experience that, it differentiates you. And if you're able to communicate effectively on the fact that, oh, I had to pivot from here to here, that I'd say that would definitely set you apart in my eyes, hiring, right? So that I think that I would definitely go for more real world.
Some awesome advice coming in so far. So Spencer, hopefully you're taking notes. Joe, what do you think?
Yeah, I agree with what everyone's saying here. Hopefully my reception's okay. I'm kind of in the middle of it. Like, I've got it something there. Perfect. But yeah, I would say one hint too. I think everyone agrees in your first project that you mentioned being awesome. I agree. I would also say that this gives you a good opportunity to help define one of the things that is my biggest pet peeve with these types of projects, which is defining what is a customer, right? And so I think if you can go through that exercise and really show your ability to not just process a data set, but also go through the rigorous definition of defining a customer, which is actually, that question is a very difficult question for, I think, a lot of companies to answer. Who's a customer? Who isn't a customer? When are you a customer and when are you not one? So if you can actually demonstrate an ability to ask that sort of a question, I know, somebody like a hiring manager or somebody, like myself or Ben or Greg would probably be like, yeah, that's awesome that you're not just doing the analysis, but you're actually taking the time to define, what is a customer that you're trying to score a lead for. So.
Awesome. Thank you very much, Joe. Spencer, how you feeling about that? Some good advice. Anybody else here want to help Spencer?
Yeah, definitely good advice. It helped definitely give me more clarity as to like just knowing that I'm doing a project that other people think at least has potential to be worth something, even if I can't really pull off like the full project. I definitely, when I was going through like the early stages, just writing up the README and stuff, and I was writing like, I'm gonna have to be flexible while doing this because I'm not sure how it's gonna work. So like I think it's important from my understanding to be flexible, but still like definitely having the goal in mind to do the project, but also being flexible that maybe you can't like necessarily force it to work, but you can at least analyze data and find some kind of value somewhere.
Yeah, man. Right on. Well, I'm looking forward to seeing what you come up with. And if you ever do want to do like a YouTube ad or any type of ad project, get in touch with me. I might have something for you. So let's go ahead and look, Greg and Eric, I hope you guys don't mind if I jump to LinkedIn first to grab some of the questions from there. Some great questions coming in. And by the way, speaking of LinkedIn, if you guys want to win a copy of Shape by Jordan Ellenberg, you can win this exact book right here by sharing this live stream on LinkedIn. Make sure you guys do that. So there's some questions coming in here from LinkedIn. One of them is, how do you go about finding data quality issues? Does anyone use Pandas profiling or Sweet Viz libraries? This is coming in from Akash. So I've used both Pandas profiling and Sweet Viz. So yes, how would you go about finding data quality issues? Let's hear from Mark on this one, and then go to Greg.
Yeah, I mean, I've used Pandas profiling before. I normally do it just as like a quick check just to get started if I'm doing that's a very quick scrappy project. But for the most part, like they have the crisp DM method. I forgot the various steps, but there is just essentially this methodology of identifying kind of like what's your data set, what's it look like, what's the data quality issues. Key things I always do is, I'll quickly view the data set, even if it's large, just like a quick head, get like 10 rows, just get an idea of what I'm looking at. I'll get the value types. So like what for each row, like, is it a string, character, and wherever it may be. Looking for null values, so getting null counts. Looking at various distributions, and then also like if you're working with like text data or categorical data, what type of are things consistent across? Those things would probably get you pretty far for the most part for a lot of things for data quality. And I guess another question is like, are you thinking about data quality for a one-off project, or are you thinking about data quality for a pipeline? Because those are two different problems with like two different ways of approaching that depending on who you are. So for me, for my job, I work with a lot of data quality issues from a pipeline perspective. And so as a data scientist, I'm not the one creating the data. So I have to work with engineering to get these things solved. And so it's just really dependent on like what's, I wish I had more clarity on where your question is for kind of like what you mean by data quality. That seemed all over the place, but that's how I think about data quality.
Yeah, it's just a huge like area, right? So definitely, I mean, all the suggestions make complete sense. Greg, how about you?
So I'm not the most versed in Pandas tools, to tell you the truth. So I couldn't tell you anything more than what Mark was saying in terms of one-off data cleanings. When he was talking, I was thinking about, oh yeah, those are the things that you can do even with a simpler tool that's been around for the longest, something like Excel, right? So you want to spot check the missing values, etc. Look at the distribution of your data, etc. And then for the data pipeline quality piece, this is one thing that I typically work on, also working with data engineers. This is key to partnering with business folks because we want to understand the origin of those triggers of data events, understanding where they're coming from and understanding why they're changing over time, and then making long-term strategy for capturing those changes and making sure that they're addressed properly. So with that, you come up with a set of tools, whether it's data sharing pipelines or data processing pipelines, or data registry versioning pipelines where you can properly monitor those things. So that's a different ball game. But to Mark's point, I don't think I can add anything else.
Yeah, thank you very much, though, Greg. That was extremely valuable. How about Russell, Eric, or Vin? Do you guys have any tips here on finding data quality issues? Crickets from everyone. Vin, go for it.
Oh, Vin.
Yeah, I was waiting for everybody else to jump in. Sorry. What I would say with data quality issues is I want to add something to what Greg was saying with the provenance piece. You really can't do too much past a surface level assessment in tools like the ones you mentioned with Pandas and so on. But there should be some metadata associated with every data set that you have. And a lot of what you have in Pandas doesn't really allow you to understand the provenance side of it. And a lot of data quality is understanding how it was collected and how it was gathered, because the gathering methodology could completely invalidate everything you're trying to do with it. So you definitely want to use the standard tools that are out there, but also just asking some questions, sometimes not even getting to the point of using tools, but just asking questions like, where was this gathered, who gathered it, when was it gathered? What was the thinking behind gathering? Just go through some of those questions with whoever it is that owns the data. And if it's like a homework assignment that you're working on or a classwork assignment that you're working on, obviously less relevant, but this is more of a real world applied situation.
Yeah, absolutely. I was waiting for somebody to jump in and talk about putting the humans in the loop, right? Talking about how did this data come to be? Where is it from? And getting that kind of background knowledge, as it were. Joe or Eric?
Can I throw something in there?
Yeah,
So
absolutely.
that reminded me, yeah, bringing a human into it is a good idea. So like I was this is about 3 weeks ago. So I was like doing one of my very first analyses here in my new job. And I like did whatever, and went and I showed my manager. My manager's like, those numbers look weird. And of course, I have no frame of reference because I've never seen these numbers before. And so I didn't know what looked weird or what didn't look weird. And she's like, that's because this particular place that you were pulling the data from only holds 2 years worth of data, and you were pulling 2.5 years worth of data. And so it holds 2 years of data for this chunk, and then 2+ years for this other chunk. And so I didn't realize it's just like some institutional knowledge that I didn't have. And I don't know, it's probably written down somewhere, but I hadn't seen it. And so, yeah, just talking to fellow humans is sometimes a good idea. So, yeah.
You can also codifying this stuff too, right? So, I mean, you're starting to see data catalogs and data dictionaries suddenly become popular. I mean, but I think anybody who has enough data, i.e. enough that you had to repeatedly use it, had been kind of documenting it in some form or another, if they had, if they were somewhat smart about it. Even just defining what are these fields? What are the expected values of these fields? What's the expected distribution? Where does it come from? I think to Eric's point, right? Like all these things that were, and now
Joe, we're having some audio issues there.
I think a lot of open source projects like data collaborate and use, and then great. So I'll type it in chat. Sorry.
Okay. Yeah. No worries. I know you're out there.
I think Eric made me think about something that used to burn me all the time. Is that when you're establishing a data strategy, is understanding the footprint that you're projecting for a company or a department over time, right? So if you know you're going to be in the US, then you can think about a very uniform way for the timestamp, right? So, but if you're going global, right? So I've collected data for global operations, and some missing values were due to, the manufacturing plants were closed at the time, right? They're asleep. So we're not collecting data at the time because the factories are closed. And I'm sitting here wondering why we can't see anything. And simply because the data wasn't collected at the uniform UTC, for example, timeframe. So it's good to understand how these systems are staged to collect data in a uniform time frame or time zone, so you can quickly translate it and be uniform across the board, especially if you have a global impact. So that's a great reminder, Eric.
Yeah, absolutely. Russell, go for it. Also, Alexandra or Nisha, if either of you want to chime in on this, please, by all means, do. But go for it, Russell.
Yeah, I've got a couple of follow-up points to the human aspect of it. So I think that we can try and do a lot of proactive analysis on the quality of the data. So we can look at the source of data, the format of the data, and try and predict the stability level of that data. Can you guys hear me okay? I think I've got some connection issues today also. You can hear me? Okay, cool. So yes, one of the biggest issues I have with data stability is the owners of the data that are providing that to us just wanting to change it because it suits them and not informing the data pipeline. So adding new fields, changing the titles of fields, column headers, etc. Adding new lines, just basically breaking the quality of the data. So with some domain expertise, you can try and predict the likelihood of that happening, try and increase the data literacy of the people that are the owners of that data to try and reduce the likelihood of that happening, and where it's impossible to be mindful that these types of breaks might happen. So if you find that there's a failure in your model, you can kind of look at these places first because they're the most likely that the issue is going to be. And then one follow-on point, which was from one of Joe's messages earlier on about figure out who your customer is. I wrote something in the chat saying sometimes the consumers can be different from the customers, so it depends on the setup. So if you're building a report or some kind of data analysis output for your customer who's asking you to do it, but it's going to be consumed by a number of people, try to be mindful who the consuming audience is. I've been in some situations where we've created some output that's been, almost cutting edge, or just really, we kind of pleased ourselves by the output and felt really good about ourselves, but it's gone completely over the head of the customers because it's too advanced for their current levels of data literacy. So we've had to roll it back a bit. So I think you do need to be pragmatic about the technology you put in for the solution to make sure that it's optimized for the audience. And that may mean that you need to kind of, swallow your pride a bit and do something that's not as good as you would like it to be, so that it's right for the audience at that time, and then try and increase their data literacy and then the technology levels of the solution in time.
Awesome. Thank you very much, Russell. Nisha or Alexandra, any?
Hopefully you got all that.
Yeah, definitely some good points there. Yeah.
I just wanted to add that what Eric said very much resonates with me, because in healthcare data, the data is essentially collected for a whole different purpose, probably for education or something else, but we use it for secondary reasons, outcomes, deciding outcomes or something else. So in that case, data quality it's not really about the data quality, because in the first place, it's collected for some other main purpose, but then it's being used because it's already there and can be used for secondary outcomes. And when it comes to data quality, it is kind of important to understand as to why to give an example, let's say there are 4 or 5 columns that actually has the dates that we want, but some columns, even though the dates are populated, you shouldn't be using it because it's populated for some other reason. And that's probably buried somewhere deep in the IT documents who essentially load the data, do the ETL process for it. But as an analyst or a data scientist, you need to know, either through talking to other people who have been there for a while, or somebody who's really aware of that ETL process, to figure out which columns you need to use. They all kind of look the same, because they all have dates, and it's still, the dates are valid, they're good quality, but you cannot still use it for your analysis. And that's not something you would want to do, because your results will be totally off. And when you go show it to your boss, okay, this doesn't make sense, that's what will happen. So I just wanted to say that like when I believe said you need to figure out where the data, how it is generated, and you need to understand that and figure out whether it's actually useful for your analysis. But overall, talking about Pandas profiling, I pretty much agree with Mark as to the purposes that we use it for. I think he covered pretty much everything that I wanted to say.
Awesome. Yeah, thank you very much. I guess we can go ahead and move on from this topic, unless anybody else has something else to add. A lot of great topics or questions coming in through LinkedIn. Eric and Greg, I know you guys had questions, but I just want to get through some of these. Doesn't look like anybody else has anything to say about data quality, so let's continue to move on. Shout out to everybody on LinkedIn. What's up, Robert and Albert? Albert's asking if it's school picture day because we all have fresh haircuts.
Hey, happy birthday, Albert.
Hey, it's Albert's birthday? No shit. Happy birthday, Albert. Hey, man.
Or was it
That's
yesterday?
awesome.
Well, happy birthday or belated birthday.
Right on, man. Happy birthday, Albert. So Antonio, comment from earlier, talking about something that he's been waiting too long to go in on. It's no code. Somebody's asking if we have any job openings. Don't ask that, please. I can't say this person's name. On India, can you throw some light on how to survive in data science if coming from a background other than math or stats? How difficult life would be without knowledge on these two. My second question is where to start the journey towards data science. So we've talked about this a lot in a lot of different previous office hours. Highly recommend you to go through my podcast, look at every single office hours and see the annotations. This is a question that gets covered quite frequently. So I urge you to please go in and listen to any one of those episodes in the podcast. There's a lot of stuff that that can help you there. So let's. Oh, I like Subash. Subash is a good friend of mine. What's up, man? Subash wants to know, what are some key metrics to measure user experience on a mobile application? To add more context, the idea is to see if adding advertising windows on a app page has any impact on the user experience. He understands that we should do A/B testing, but he's not sure what metrics should be captured to measure user experience. That's a great question, man. I actually really like that. Let's go to Vin on this one, then hear from Mark, because I know Vin's got a ton of experience on this, and I know that this is something that Mark works on with Humu as well. Then Rashad, if you got any insight on this as well, would love to hear. But Vin, go for it.
We're talking about apps, right? Like mobile apps, you said?
Yeah, mobile application, key metrics to measure user experience on a mobile application.
One of the ones that I just love is if you're doing A/B testing, look at the flow, the difference between flow for with ad, without ad. And that can be everything from time on page or time completing a particular task, or I don't know what kind of app you're using, but essentially look at the time that two people would spend, one versus the other, doing something, and figure out if you've gotten in their way. And try to understand, when you think about impact on the user, exactly how much time they used to spend on that page. If they're reading something or playing a game or whatever it ends up being, how long did they spend in that particular flow before the ad and after the ad? Because you find so many different things by understanding just how people continue to use, or in some cases, like you see the time on with that particular ad plummet, and that's a horrible sign, because now you know that it's drastically impacted. So you're looking for big, drastic changes in the time people are taking doing a particular thing versus what they did before.
Thank you, Vin. Yeah, I remember we were talking about this a couple of weeks ago as well. Mark, I think that was you that was having a similar question. First of all, how did that situation work out for you, and what insight can you provide Subash here?
Yeah, I haven't had a chance to work on that project because things always pop up when you're at a startup. And so I've been working on other things. But it's interesting. I was like listening to Vin. I was just like, wow, that would be really nice if we had the infrastructure to do those things. So more so talking on the early side of like, how do you analyze? And I think this ties in back to like Spencer's question of like, you know, you're throwing these quirks in your data where you don't have access to things. So like, how do you still drive value? And so for me, it's just like just getting logs of data. And so I'm always like pestering our engineering team whenever we're building new features. I'm like, so what are the logs going to look like? How are you going to structure it? What are the values? How are you going to define this? They kind of get annoyed, maybe, I don't know, because they're so busy themselves. They're like, why are we going to worry about this? I'm like, just get the logs. Where are the logs at? And so I think biggest thing is like getting logs and being mindful of like, where do you want to log? Where are the time spots in which like, what's an event that's really important that can like inform you when a user's reach a certain point? So like, I don't have access to data of like, where were they clicking and how long they're on for it. But I know when they get to a certain page, I know when they go through a certain workflow within our app or within different channels. And so having those specific logs, and more importantly, being a startup, there are different channels and different sources, bringing them all together into one table where I essentially have a snapshot of like, I know how a user moved through our product, basically for all of their lifetime as one of our users. Event hooks, that's what you're talking about. Yep. And so, yeah, we have things like that, but it's like, again, prioritizing, like, do we spend time building out these hooks versus building new features, which is always a balance. So with the data I do have, things I look at is just like, just different rates of like opening, closing, going through, how far people made it through. So like things that you want to look through is like funnel analyses or click-through analyses. Those are kind of the things that I'm thinking about a lot for that. But I think something that probably make you really effective, even before thinking about the metrics, is like thinking about like, what type of data is impactful to even get in the beginning, and like influencing people who are building the product to like care about those values, to like actually measure, and then making it clear to them that like why measurement's important. Because the argument I normally use is like, wow, you spent all this time building this product feature. It'll be great if I can mathematically show it's awesome. And that normally gets gets the buy-in.
Thanks. I like that last bit there. Greg or Rashad, any input here?
I wanted to add something real quick. Oftentimes we say we want to test, and by the way, this question is very close to the question I have. I am so happy about this question, and I've enjoyed listening to Vin and Mark. So that's pretty awesome. But oftentimes we want to do an experiment, and then we say, well, how do we validate that it's going to work? Well, before you run the experiment, what I can tell you is you need to define what success looks like to you, and then work backwards from that. And then say, okay, I picture success as this based on my hypothesis. And then what are the key inputs that will translate those success? Are we actually collecting these inputs already? Or do we need to start creating ways for collecting these inputs? And then when we run the test, we go take a look at the inputs and we look at the behavior post-experiment, and then we say whether it works or not. So if activities increase when you run marketing on an app, then you can go through these inputs to see whether click stream increased, et cetera, et cetera. So always start with what success looks like in mind, and then move backwards in terms of what does it take to measure that success? What are the key inputs to take a look at those outputs?
Very, very practical and valuable advice. Thank you so much, Greg. Rashad, anything to add here? If I recall correctly, you work with like apps and stuff like that, right?
Actually, no. At the moment, not really.
Okay.
Although I do use Plotly Dash as my preferred like visualization for users. But I wouldn't say I've actually never really worked with mobile apps. But I will add, I do think I have something to add. I would suggest that if you're thinking about the total user experience, oftentimes it's not just the mobile app itself. And if you expand your definition of what the user experience is and what they're trying to do, you can get a clear idea of the cost of doing things like adding ads and making the interface slightly more clunky. So for example, if you have an app and if the person's trying to do something in the app, and if they can't do it in the app, they will call your call center, right? So that's outside the app, but it's like really, really important for business outcome because the call center is a much greater cost, and the user was trying to do something and the ads make some subset of users less able to do that thing, right? That's really bad. And so I would say like the user experience, also think outside the app and consider if you can measure that more omni-channel data, especially if you think of like a specific outcome. I mean, banking apps, for example, have lots of very specific things that users are trying to do. So that's relatively probably easier to constrain that problem, but it really depends on your app and the total universe of what the user could do and what the cost of those things are.
Awesome. Thank you very much, Rashad. Appreciate that. Subhash, you got a lot of good insight there. This is recorded, obviously, so you can catch that later. Don't see any more questions trickling in from LinkedIn. Speaking of LinkedIn, if you want to win a copy of this book right here, this is Shape by Dr. Jordan Ellenberg. I released a podcast episode with him today, New York Times bestselling author of How Not to Be Wrong, Power of Mathematical Thinking. You could win this book. Just share this live stream, tag me, tag Vin, tag Mark, tag Greg, spread the word, try to get these things blown up and big. So no more questions coming in from LinkedIn. So let's go straight into Greg's question, and then we'll go to Eric's question. Anybody else got questions at all? Let me know right there in the chat, wherever it is that you are viewing this. Go for it, Greg.
All right, so my question is just about anyone who wants to answer this. We talk about data science projects where the data is there, we do some cleaning, et cetera, we train the model, et cetera. Well, let's take a case where we have a supervised learning where the data is not yet labeled and we want to test for causation. We have some hypothesis we want to test. And we want to go beyond the A/B testing. I want to hear from you guys any use cases about experiment you ran, you tested, you collected data, and were able to label your data, and then use that collected data to train your model and deploy to production. So, in other words, who do you work with? How do you design these experiments? What is your control group? What is your treatment group? How do you make sure that you put a stamp on that causation to make sure you move forward and confirm that, yes, ML is a solution for the problem you're experiencing?
Yeah, that's a good question, man. I'm gonna have to think on that one. I was gonna say I interviewed Alyssa Simpson Rockwerger yesterday, and she wrote this book called Real World AI, and the company that she used to work for is called Appen, and they were data annotation company. So definitely look into that work, the work that she's done. I mean, I could probably talk about the experimental design part, but as it relates to annotation, man, I'm not sure. Mark, I know you've done a lot of work in experimental design as well. So if you have any insight, definitely chime in here. Rashad, Vin, anyone, go for it.
I was about to say, I just posted this in the chat. I recently read an article that was really interesting where it said, be careful when interpreting predictive models in search of causal insights. Because, and again, I think they're way more advanced in thinking about these kind of things for that. They're like a bunch of Microsoft researchers. But essentially, like the argument they're making is like with predictive models, you're looking to the future, but when you're trying to show causality, that's more of a like looking in the back, understanding a relationship. So I thought that was a really interesting article that really teased that out for me. And so when you're asking about like causality and like how to prove that, I was thinking like two sides of like, my mind doesn't go straight to like machine learning. My mind goes to like setting up like a randomized control trial, and this is coming from like my healthcare background, or doing observational studies. And so the gold standard would be the randomized control trial. Those are really expensive. So like thinking about your inclusion exclusion criteria, like who's in this population and how do you make them similar enough where you won't have confounding, and then randomizing that to control for confounders, unviewable confounders you don't measure. I'm blanking on the name of it. So there's that component, right? But that's really hard to do, especially in the business setting. Like that's a lot of investment. I don't see that really happening. You do it for healthcare because you don't want to kill people with drugs. So that's why they go through all that. But like many times I think about data science, observational studies. And so there's different methods. There's a question in the chat, confounding variables. I'm gonna get back to it. It's gonna bug me. I'm gonna put it in the chat what I meant by those words. But essentially, unobserved covariance. There we go. Unobserved covariance. That's the thing you want to look out for. And so when you do observational studies, is that you already have a data set that you already have available to you. And many times you didn't collect it yourself. So you don't have control of the experimental design. But here's the thing, you have observed confounders, which you can control for with special statistical methods, but the unobserved ones you can't. And so when thinking about that, again, you go back to what's my population and what's my treatment and control? So who got the pill, who didn't get the pill, who got the intervention, who didn't? And how can you create like similar populations between the two? My favorite method of all time is propensity score matching. I love it. It feels like magic. Essentially, you create two similar profiles where you can just do a simple like t-test or regression. You can see kind of the difference between them. But it goes deep. There's so many different methods, like instrumental variables, all these different things you can do. And so I think it really comes down to is like not even the statistics, but how do you frame the problem to know that you have two separate groups? And how do you measure that bias and put kind of tools in place to like say like, not even reduce the bias, but point out here's the bias and this is how we kind of account for it, to give you a better idea of how to like show that causality between things to make a better decision to move forward with. And from there, you can take those insights to do like predictive model.
Yeah, exactly. So I think you're on the right track here. You said it very well, because in my case, it's like a use case is we want to gain more, we want to turn prospects into, we want to convert them. And we want to test, for example, an experiment. We want to offer them some sort of marketing campaign. And in that marketing campaign, we will reduce the price of our product by 20%. And we will select a group who will receive that campaign and select a group who will not receive that campaign and observe and collect data and then see what happens. And that data collection, now you can use that to train a model, because now the model has annotated data that tells them who converted based on that campaign you ran, on that experiment you ran. and who can tell you who will not convert, so you can deploy it. And now you know who to target, better target for these marketing campaigns. So in real life, when you run these experiments, it takes months. So that's why, data science projects, we often think it takes 3 months, but it can take years. It takes time to run these experiments. So that's why I wanted to get the conversation going in terms of what other use cases, what kind of experiments have you done before outside of marketing, outside of A/B testing? What other use cases are you seeing on your daily lives? Do you work with economists? Because economists, all they want is behavioral economics, right? So that's all they care when it comes to causality, right? You do this will cause me to spend more money. You don't do this, well, I keep this money in my pocket. Those are the things that I wanted to talk about today.
I think one thing that I want to add real quick that makes it so hard doing a business use case is like when you have a customer who's paying for it, many times they don't want to be experimented on. They don't want to be the one that didn't get the treatment or got just like the best use case. And so it's really hard to push that. And also I think another challenge is that when you do an RCT or just like experiment, like what if it doesn't give you the result that you want? And so many times, which is science, that's fun for us, but for like the business stakeholder, that's a level of like risk that they don't even want to engage in. They don't even maybe want the answer. So I feel like doing the controlled trials or like showing that causality, it starts getting into like the politics of things sometimes and I think it reminds me of your comment you always make. I always go back to it, like what's your business stakeholders risk threshold? And experiments definitely steps on that, I've noticed.
Yeah, it's a thin line to cross, that's for sure.
Yeah, I mean, but just other use cases, like, I mean, as a biostatistician, like my whole job was designing experiments and coming up with randomization schemes and experimentation schemes. And so I've seen a wide range of them. I've seen like bioequivalent study where we're trying to figure out if two compounds are equivalent on one particular endpoint. Do they do the same thing? You could do studies where you're looking at dosing studies where you're trying to find out the optimal dose to dose someone. So you have increasing dose levels and trying to figure out what impact that has on some endpoint. Also, there's we did this flu design, this flu study, and the design was taking our drug, comparing it. We couldn't compare it ethically to a placebo because you can't just, like, somebody has severe influenza, you can't give them like a sugar pill. So we give them the standard treatment, which at that point was Tamiflu. So that's almost like a bioequivalent study, and just seeing how our drug works against that, and things like that. Anybody else? Nisha, let's hear from you, because I know you're doing some hardcore science as well. And if anybody else wants to chime in on this, let me know. And if anybody else has questions, let me know as well. Nisha, oh, there you go.
Hey, so I just wanted to comment. I've not had a practical use case for this. It's more theory and more coursework oriented. So developing a probabilistic graphical model, usually in colloquial terms called a Bayesian network, essentially helps you tease out causal inferences as well, as far as I know. I've never had done a practical use case on it, but this is done in the health domain very often. So trying to figure out if one particular drug is going to work on a patient or not in a big hospital, then you create a graphical network from the data that is available from an EHR, including the claims data, whatever data you can get your hands on, and the payroll data. Putting together that network definitely requires putting together that network is the tough part, because that requires domain expertise. Once the network is good, then you can dive into the causal relationship that happens within the network. And you can ask any kind of question to the network that it would give you a probability-based answer. So you have a level of confidence on how a particular variable is going to affect your end target variable. Check out, if you're trying to implement it, I'm trying something similar to it for my thesis currently. And I'm using PySmile. It's a Python plugin for Smile Engine, which is essentially a graphical network, and it essentially draws out the network, and you need to figure out what the network is. And that's what I'm trying to utilize to generate my network, see if I can make it a proof of concept model. So hopefully that helps. So I've not had a practical use case yet. It's still in a theory mode, and I'm trying to figure it out myself. And I've got a nice book. It's around somewhere. I've been reading on and off. I can send you that if you're interested.
Is the work you're doing at all related to like the stuff Judea Pearl is doing with like the causal inference and causal models, like the Book of Why? Is that because he does these causal diagrams, and it sounds similar to what you're talking about? I was curious if that was some overlap with that. That'd be pretty interesting.
The question that I'm interested is not really causal based, but in the due course of my research, it does say that when you design a network, you can have causal inferences as well, rather than going through a proper factor analysis or through a proper RCT, which is just a lot of time and money in my domain, in healthcare domain as such. So that's how I know that it can be applied to that as well. I just haven't quite dived into that particular aspect of it, but I know it's applicable to it.
And for anybody else interested in like designing experiments, Penn State has a great, like Penn State's statistics department is like my favorite, even though I didn't go to school there. I love their stuff. They have this awesome introduction to the design of experiments course that you can just kind of go in through, and it's all just like really well thought out notes, and just the entire course really quite interesting and really really comprehensive. Highly recommend that. I'll put the link to that right here in the chat. Anybody else have anything to add on this topic? Vin? Skip Vin, sorry.
Hi, Arpit.
Hey, how's it going?
Yeah, I'm doing well. So I just had a question to Nisha. I think she pointed out some a specific word network, right? So in the context of that explanation, I was curious to understand what that network is, and how does that relate to the end outcome, which they usually they want during the project.
Nisha, did you step away, or are you still there? Looks like Nisha stepped away, but definitely look Nisha up on LinkedIn and send her a message. You might be able to provide you more insight. And Nisha, if you did hear that question, definitely let us know what you meant by networks in the context of the work that you're doing. Don't see any other questions coming in through the LinkedIn or chat here, so we'll move on to Eric's question. Eric, go for it.
Yeah, so I have been trying to think of, been trying to find a data set to analyze related to bias, like bias in general, to be able to see how it could be in a model, right? And so actually even just like defining what a data set like that would look like is actually pretty tough. Like Mark and I were talking about it, and it's easy enough to see, like you can see injustice in data a lot easier than you can find modeled bias. Or I guess I should just say it's like a much like smaller subset of data, right? And so just my question is, I'm going to like give my working definition of what this needs to look like, and I just want any ideas anybody has about like what kind of data might fit into that. So basically, I'm looking for something that is there's a desirable outcome that somebody is trying to attain, like a job, a promotion, parole, something like that. But their ability to attain that outcome is dependent upon the decision or verdict of someone else. And that's where the bias comes in. And trying to figure out where I can find that data.
You can probably look at like all of the court data that comes out of like the Supreme Court of Alabama. I'm sure that will have a lot of bias, and I'm just making stuff up. It's a good question. If anybody has any insight here, I'd be happy to hear it. Rashad or Mark or
yeah, I mean, I can't give you like this is the data set you should look at, but in real estate, this is like a big deal historically speaking, because there's something called redlining, which many people are familiar with, but it's the idea that zip codes were labeled based on their racial composition at certain times in the 20th century. And this affected the ability of people who lived in those zip codes to get loans. I would say, so you could look for, trying to think like what the data would look like. I mean, loans, mortgage data, having that connected to demographics of the receiver could be difficult, I imagine, but I'm just brainstorming here, to be honest.
Yeah.
Other things are just lending in general, because lending, big driver of the economy and jobs and business formation and whatnot. And you could imagine that lending standards have varied by, that they've been unfair to certain groups, especially if you can get historical data. My guess is that government data sets like data.gov might be a good place to start to get something like that.
Yeah.
Those are like the biggest examples of bias I could think of right now.
There's something that's kicking off my head from that. And Mark, not Mark, Eric, let me know if this is kind of in line with what you're looking for. Is like, so city of Winnipeg, for example, we have data like in our open data portal, and we have data that is there's a data set that has all of the parking tickets that were handed out in the city, right? And it says the neighborhood as well, and the like latitude, longitude, neighborhood as well that the ticket was given. We also have demographic data for each neighborhood that includes stuff like median household income, racial makeup, and things like that as well. So if you combine those two, then maybe you can test the hypothesis, like, are police giving out more parking tickets in poorer neighborhoods? Would that kind of fit the definition of the type of thing you're looking for? Is that kind of off the mark?
So I think it kind of fits like the front half, which is detecting the bias, right? Mm-hmm. So we, that's like I was saying, like that's detecting injustice, right? You can see like, hey, police are giving more parking tickets in a disadvantaged neighborhood, right? And so the other half, and this is this thing I'm just trying to wrap my head around, is like, how do you like mitigate the bias, right? So if you detect it and you can see, like, I'll use promotions as an example, right? So if you can look at the various factors that go into getting a promotion, and you can show that the difference in men and women are like, men are more likely to get a promotion, like X% more likely to get a promotion, then you can compensate for that in like, either you can, Vin's like, no, nothing, not that. So like, how do you address it? Even how do you see it? How do you address it? Like anywhere.
Vin, go for it.
You mind if I dive in on this one?
Absolutely.
Please.
Yeah, that exact, I worked on that exact scenario. You cannot debias a data set after the fact. You just can't do it. And I will argue until I'm blue in the face with people. I have argued with very, very smart people. You can't debias a data set after the fact. Once it's gathered, once the bias is baked into it, that bias isn't just in what you detect, it's everywhere. Every outcome, every label, everything. You are learning from a data set that's biased. The only thing you can do is regather it, especially when you're talking about policy, which is where you're getting into. You're not talking about like hard outcomes. You're not talking about, a car goes 100 miles an hour, the person dies because of the collision. That's a hard outcome. You're talking about policies. You're talking about somebody making a decision and doing decision support based on a recommendation that you're giving. Mm-hmm. And so when you do anything that recommends policy, and this is an interesting, kind of going back to what Greg was talking about and asking about with causal, there is a lot of causal analysis and causal graphs created to support policy decision making and to support models that are used for policy because of exactly this. You inevitably have bias in your data, and unless you go through the process of that initial model's a hypothesis, you're going to find that bias in the data, and then you have to, starting from that hypothesis, go back and build a new data set without the biases that you've detected in your initial data set. And you also have a ton of other concerns, obviously, in regathering data. But one of the big ones, and one of the reasons why causal inference is used so much in policy recommendation, is because it's a nod to this, that you have a biased data set. And once it's biased, it's done. You can't build a reliable model based on it. And so you have to use that as a starting point, not an ending point. And there is a consensus opinion in some companies that you can debias data sets, and it never works. Every single time someone has tried this through any number of debiasing techniques, it's failed. The bias has been discovered in the data set through some other type of feature engineering, and it ends up in the model. So
Sure.
what you're doing is really related to the policy space and the policy recommendation space. And so if you go down that road, you're really now walking down almost a causal inference and creating causal graphs and then validating those causal graphs to support the policy which any given model recommends. And so you're going in that direction. I think that's where you're going to end up, is that there is a primary and a secondary and usually a tertiary data gathering process. And that first data set that you use, you can definitely use it to identify the bias in the data set so that the next data set that you gather doesn't have the same biases. So that's one way of handling it, but it's not exactly talking to the exact use case that you're referring to, I think.
No, that's really helpful, just because it's, obviously, like when you say it, like, well, once the bias is baked in, it's in there. It's like, well, yeah, I mean, garbage in, garbage out makes sense. So yeah, that definitely, and I think I need to like think through a little bit more what the actual use case, like the final kind of use case is. It's just nebulous and big. So thanks.
Mark, go for it.
Yeah, so I've actually been talking with Eric about this use case for a little bit. So I've been quiet because I'm just trying to listen as well. But also I want to get feedback on like a potential approach that we pitched. Was essentially is like going back to the policies that you have, going back to like sentencing, right? If someone's sentenced for a certain time for a crime, you can tie a specific crime to a specific law and give you recommended years from like the lower limit and the upper limit. And so maybe there's a potential way to feature engineer, like someone has their basic demographics, they have their sentencing time, and feature engineering a value that's like, where does it fit within that range? Is it really far up, really far below? And taking those differences, and maybe like a way you can detect bias is putting that on like a normal, not normal distribution, but like how many standard deviations is someone's sentence compared to like other people. And that's more of a statistical way to see like, I don't even necessarily finding bias, but it's more so finding outliers and therefore a proxy for bias. Would that be too much of a stretch for identifying, just a starting point being a labeled data set of like, these are potentially biased instances? And that was probably a lot in like a quick second. So I maybe have any repeat or just like talk to someone one-on-one.
If anybody has anything to add on to that one, go for it. I mean, it's a great topic, and I'm just doing a couple quick Google searches here, and hopefully I can find something useful for you here, Eric. I'll send some links right here in the chat. While I'm trying to stall for anybody who has something to say on this topic, let me just pull up what I found real quick.
Sounds like you need to Vince's point, you need to run a couple experiments and test them. Like if you have such biased data set, to see what the hypothesis says. If you would run some experiment to check whether the bias goes away, and then you would use that collected data to train a model. Is that what you would want? Is that what you meant then by, once bias is over, and you would need to introduce another set of data on this? Just wanted to make sure I understood your point.
Well, actually, Mark's kind of clarified, and I can tie both of these together. So, Mark, the bias was introduced before the data set. And this is the key piece to understand, is that when you're looking at defendants who are charged with a crime, that in and of itself has already been impacted by previous bias. How likely is it for any given person to be charged with this crime, given the same facts of the case? And so that would be the data set that you needed to gather, because that would inform you about biases that exist in the data set that was gathered about sentencing, because you already have entered this entire process with an initial bias. And so that's really where you begin to do experimentation, is you're experimenting with what came before to figure out where bias begins. Because you want to look at, you have to find the origin, the first step that introduced bias into a process. And then in order to build a model, you have to gather data in some way that removes the bias from the process in order to create a model. Now, if your whole purpose is to discover bias, again, same process, going back to now that initial step and saying, okay, the decision to charge, what came before the decision to charge? Well, it was the decision to investigate. Okay, was there bias introduced in that part of the process? And you create this complex chain where you say this thing has an origin, and a lot of your experimentation is really walking back the chain to find the original insertion of bias into the chain that you're measuring. And that's where you have to start, because if you start trying to find bias later, you're, like I said, you're done, because that data set's already got the bias baked into it, and it has biases baked into it that you're unable to measure because you don't have enough data to understand it. And so it's the same process, two different outcomes. So when I say experimentation, in many cases, to find that upstream process, I mean, I'm using a really simplistic example in this case. Typically, if you're doing something like marketing, there's a level of, I just can't get to the origins of a buying decision or the origin of a search with intent decision. And so, obviously we're using a very simplistic experiment. So example, so it's obvious where bias may have been first introduced into the process. But when you look at more complex processes that you don't necessarily have full control over or full access to in order to perform each one of the experiments, that's where the experiment comes into play to understand how bias exists, because all you have is data at that point. You can't do a physical experiment, so you have to do an observational experiment with an existing data set, knowing that there's likely bias in it. And so you have to design your experiment such that, number one, you first find the bias that's in that data set. But number two, you're also working backwards to figure out where, how far can I get down the path feasibly, and costs come into play here. And this is kind of going back to Greg's question as well. Your cost comes into play because how many steps are you really going to trace in a very complex decision chain, like buying or something like that? And how much data can you actually get access to? And in each one of those phases, you're looking for two things. Number one, there's bias in the data someplace, and you have to find it and improve your data gathering process. That doesn't mean your data is worthless. It just means you can't rely on it because bias is there. And you may end up making some bounded statements where you say, my model will likely perform well in these scenarios, however, it won't. And you talk about how bias plays into the bounds of performance and accuracy for your particular model and the uses that you can touch on and control really when this model should be used. And that's a lot of what you're talking about, Mark, and also Eric. You're talking about trying to understand the bounds of utility for a particular model. And so and I'm sorry, I know I just kind of threw like the planet at you, didn't I? My bad.
So it's amazing hearing from you, Vin, and I can only go back to my manufacturing roots, lean principles, asking 5 whys, going back to the root cause. I mean, we're really not changing anything in data science, really, when you think about it. Agile methodologies, lean principles, I mean, job instruction training, it's really not changing, right? Those are the things that we've come up with in the early 1980s or whatever for software development. For Toyota came up with it in the 1800s and stuff, and we're just regurgitating those methods to go back to the root cause. At the end of the day, that's what it's about. So I think that's where you go into when I hear from you. So that's pretty awesome.
Yeah, we just have way better tools and a whole lot more data. So we can do a lot of the things quantitatively that we used to have to do heuristically. We used to have to rely on expertise far more And now we can apply a more rigorous process to treat the data to understand the complexity of the system that we are actually interacting with.
Correct.
Awesome. Well, thank you very much. Alexander, I saw you had a great point to make in there. So definitely go for it.
Oh yeah, I mean, obviously the conversation has kind of gone in a different direction, but I was just trying to think back to some cases that might have been applicable before we kind of had this head explosion moment. And I've done, not from a statistical point of view, but more from an economist point of view, some work with the Innocence Project and the idea of wrongful convictions and the difference between what the sentence outcome would be for people that use the public defendant versus a private attorney. So I know we've kind of like gone in a different direction now, but I'm not sure if even that type of question or idea would spark anything related to this idea of data set bias.
And I mean, to that point, I've dug up this kind of resource that I will share a link in the chat. I think it's very applicable to everything that people have said already. And it's talking about a quantitative and qualitative assessment of bias in data. Short read, 12 pages, and just really great questions for you to consider when trying to think about bias in data. So I'll go ahead, I'll just share that link here. Hopefully it's useful for you guys. And looks like the reference section, yes, reference section looks pretty good too. So might be able to find a couple of good references there. All right, guys, does not look like there are any other questions coming in. So thank you so much for taking time out of your schedules to be here today. I appreciate you guys coming and hanging out. Great discussions as usual. You guys make my Friday evenings that much more better, man. Thank you guys for being here. Remember, you can win a copy of Shape by Jordan Ellenberg. Definitely tune into the episode, released that earlier today. Just share this very live stream on LinkedIn. Do it from now until Monday, and then on Tuesday I'll pick a winner and I'll post about it. So this is a great book, highly recommend it. Actually talks about hidden geometry of bias and stuff in here as well. They got an entire section on gerrymandering and politics and things like that. But guys, thank you so much for hanging out. See you guys next week. Again, man, excited to have you guys here. Take care. Remember, you've got one life on this planet. Why not try to do something big? Cheers, everyone.